This is 6.4 practice. Number 1, a large mail order company advertises that it ships 90% of its orders within 3 working days. You select a simple random sample of 100 of the orders in the past week for an audit. P is the proportion of orders in the last week that were shipped within 3 days. Okay. So the mean, the mean of all of those 100 samples of 100, a whole bunch of them, the mean would be 90%, same as a proportion. Standard deviation of it would be the square root of 90 times 1 minus 90, or 10%, divided by n, which is 100. And if I get my calculator here, whoops, okay, 0.9 times. I have a standard deviation of 0.03. Okay, and then part B says to interpret what that standard deviation means. The proportion, the percentage of packages shipped within 3 days will vary from the mean of 0.90 by about 0.03. Okay, number 2. Deals with that same thing. It says, would it be appropriate to use a normal distribution? Okay, so I know that n times p and n times 1 minus p has to be greater than or equal to 10. Okay, so that's what I'm looking for. So my n times p, there's 100, and I have 90% of them are on time. So I would expect 90 of them to be on time. And that means 10 of them would not be, so I would expect 10% would be 10. Both are greater than or equal to 10, therefore that they are approximately normal. Shape with this mean and the standard deviation. Okay. Third problem. Suppose that 70% of college women have been on a diet within the last 12 months. Seems kind of high. I don't know, though. A sample survey interviews a simple random sample of 267 women. Find the probability that 75% of or more of the women will have been on a diet. Okay, so let's find what the mean would be. So I know the mean would be equal to 70. The standard deviation of 267 women. Okay, standard deviation of 0.028. Okay, I know that, okay, that's the first part. N times P and N times 1 minus P to see if I can say that it's normal. So 267 women, 70% of them. I would expect 186.9 if you want to have been on a diet. And I would expect 80.1 of them to not have been on a diet. They're both greater than or equal to 10, therefore I can say it's approximately normal. Okay, and then to get to the last part there, I know it's approximately normal. I know my center's at 0.70, it has a standard deviation of 0.028, and I want to know the probability that I get 75% or more. Okay, so 0.75% or more. Okay, so you go to your Desmos, your normal distribution there, and you find that probability. Okay, so from from using Desmos and normal dist, I know the probability that my proportion is greater than 75% will be about 3.7%. Okay, number 4. Harley-Davidson motorcycles make up about 14% of all motorcycles registered in the U.S. Okay, so once again, I can find my mean. It's going to be 14%. Standard deviation. And it says here we're going to sample 500 motorcycle owners. So divide by 500. Can I get a standard deviation of 0.0155? Okay. Check for the normal, n times p and n times 1 minus p. So 500 people, proportion is 14%, would be 70 people. And then 500 people minus 1 minus 15% would be 430 people. Both greater than or equal to 3. Greater than or equal to 10. Therefore, their shape is approximately normal. We really talked about it, but if it's not approximately normal, then you just kind of stop. You can't really approximate it. So we know our center is at 0.14. I know the standard deviation is 0.0155. Okay, and we want to know what's the probability when I get 500 that I'm going to have 20% or more. Okay, so 20% or more. Probability that my proportion is greater than or equal to 20%. Okay, I'm going to go to Desmos and get that. Okay, when you find that, it's an extremely small number. I shouldn't even actually have this much there. It should just be like right there. Okay, so if the true proportion is 14%, if I'm serving 500 people, I will ever really get 20% of them having Harleys. Okay. Next problem. Drinking the cereal milk. Okay, USA Today poll asked a random sample of that many U.S. adults what they do with their milk in their cereal bowl after they have eaten it. I drank mine. Let P is the proportion in the sample who drank milk, and they claim that 70%. Okay, so this is question number 5. We know that the mean they claim to be is 70%. The standard deviation we're surveying 10, 11 people. 10, 12. Okay, I get a standard deviation of 0.0144. Okay, that's part A. Part B. Is it normal? N times P, N times 1 minus P. So 70% of the people, of that many people. Gives me 708.4 people. And that many people times 1 minus the proportion gives me this many people. So both are greater than or equal to 10. Therefore, I can say my shape is approximately normal. Okay, then part C. I know it's approximately normal with a mean of 70% and a standard deviation that is 0.0144. Okay, calculated probability that at most 67%. So at most, so that's the greater number. So 0.67 and less is what I want to find here. Okay, I've drank their milk. So I'm going to go to Desmos. I'm going to pause this, go to Desmos, find it. Okay, so from Desmos there, we have this probability, 0.01686. Okay, and our last problem, refer to that problem we just did. 67% said that they drank the cereal milk. Based on your answer, does it give you convincing evidence that then less than 70%? Okay, so if I got a sample that was at 67%, that would happen a little over 1% of the time. Does that give me evidence that it is not 70%? Well, it only happens this percent of the time, which is it's kind of low. So I would say yes, it is not probable. So to get, well, let me say this, not probable to get a sample of 0.67 or less. So the true proportion is most likely less than 70%.